Right now, as you sit here listening, your body is already making decisions about energy, survival, and storage. Beneath your skin and wrapped around your organs live tens of billions of fat cells. They are not passive, they are not broken, and they are not waiting for a diet to save them. They are listening. Every step you take sends information through hormones, nerves, blood flow, and enzymes. And within minutes of walking, not weeks or months, those cells begin to change how they behave. This film is not about weight loss tricks. It is about understanding what your body is already designed to do. Because once you see what actually happens inside fat tissue during a simple 30-minute walk, something fundamental shifts. Your body stops feeling like the enemy, and movement starts to feel like communication. For decades, fat tissue was taught as inert storage. Extra calories go in. Calories burn off. Fat shrinks or grows. That model is outdated. Adipose tissue is now recognized as a fully active endocrine organ. Fat cells secrete hormones, cytokines, signaling molecules, and metabolic regulators that influence insulin sensitivity, inflammation, appetite, blood vessels, and even brain function. An adult body typically contains between 30 and 40 billion fat cells. Each one operates like a regulated warehouse, not a garbage dump. Inside each cell are triglycerides, tightly bound molecules designed to store energy safely. This matters because free fatty acids floating uncontrolled in the bloodstream are toxic to organs like the liver, heart, pancreas, and kidneys. Fat cells exist to protect you. They expand when energy is abundant to prevent metabolic damage. They release energy only when conditions are safe and signals are correct. When fat cells become overloaded for too long, inflammation rises. Insulin signaling weakens. Blood vessels stiffen. Metabolic disease begins not because fat cells fail, but because they are forced beyond their intended role. Walking changes this relationship. Your body evolved in an environment where movement meant survival. Walking signaled migration, food seeking, safety, and normality. Sedentary stillness was historically associated with injury or starvation. Because of this, your metabolism does not respond to exercise as a math equation. It responds as an information system. Walking tells your nervous system that energy is being used steadily. It lowers baseline stress hormones over time. It improves blood flow distribution. It shifts hormonal priorities from storage toward balance. Unlike intense exercise, walking stays within a metabolic range your body interprets as sustainable. That interpretation is everything. This is why walking produces effects that far exceed what calorie counts predict. It does not fight the body, it reassures it. The moment you stand and begin to walk, your nervous system responds. Heart rate rises slightly, blood vessels dilate. Muscle contractions increase glucose uptake without needing insulin. During the first few minutes, fuel comes primarily from circulating glucose and stored glycogen. Fat release has not yet peaked, but inside fat cells something crucial has begun. Adrenaline and noradrenaline rise gently. These hormones bind to beta-adrenergic receptors on fat cells. This activates hormone-sensitive lipase, the enzyme that initiates lipolysis. At the same time, insulin levels begin to fall slightly. This matters because insulin actively suppresses fat release. Lower insulin removes the brake. Adrenaline turns the key. The system is warming up. By 10 minutes into walking, lipolysis is fully active. Triglycerides, inside fat cells, are broken into free fatty acids and glycerol. Blood flow to adipose tissue increases, allowing these molecules to exit efficiently. This is a frequently overlooked point. Fat cannot leave fat cells without adequate blood flow. Walking improves delivery routes. As fatty acids enter circulation, muscles begin shifting fuel preference. Mitochondria increase fatty acid uptake and oxidation. Energy production becomes mixed. Glucose and fat are burned together. This metabolic flexibility is a marker of health, and it is trained through repetition, not intensity. Many people stop here. They miss what comes next. Between 15 and 30 minutes, Fat oxidation reaches its peak during moderate walking. At this intensity, roughly half or more of energy expenditure can come from fat. This has been demonstrated repeatedly in metabolic chamber studies and tracer research. More importantly, fat cells are learning. Repeated exposure to this signal increases enzyme expression involved in fat breakdown and transport. Proteins like CD36 and fatty acid binding proteins become more abundant. Mitochondrial efficiency improves. Walking also stimulates the release of irisin from muscle tissue. Irisin acts on fat cells, encouraging white fat to adopt characteristics of brown fat. Brown-like fat burns energy to generate heat. It improves glucose handling. It reduces inflammatory signaling. This is not cosmetic fat loss. It is tissue reprogramming. When the walk ends, metabolism does not immediately settle back to baseline. Lipolysis remains elevated for hours, continuing to release fatty acids that support muscle recovery and the gradual restoration of glycogen. Mitochondria stay active, quietly converting fuel with efficiency even after movement stops. This is often called the afterburn effect, but the term falls short of the reality. What truly remains is signaling. The body continues to operate as if movement is part of its environment, not a temporary event. With repeated daily walks, this assumption strengthens. Fat cells become smaller not because they disappear, but because they release stored energy more willingly. Smaller fat cells are less inflamed, more insulin sensitive, and hormonally healthier. They secrete protective signals, such as adiponectin. This is how a virtuous metabolic cycle takes shape, reinforcing balance long after each walk ends. Decades of research show that regular, moderate walking reshapes metabolism in measurable ways. Lipid profiles improve, visceral fat declines, inflammatory markers fall, and insulin sensitivity increases, often without aggressive calorie restriction or extreme effort. These changes accumulate quietly, driven not by intensity, but by repetition. High-intensity exercise can be beneficial, yet it also raises stress hormones and pushes the body back toward glucose dependence. Walking keeps the system calm and predictable. It signals safety rather than urgency. This helps explain why populations with high daily step counts often show remarkable metabolic resilience despite varied diets and lifestyles. Movement, when consistent, normalizes the system. Duration matters far less than frequency. 30 minutes each day consistently outperforms longer sessions done sporadically. Your body does not adapt to what is extreme. It adapts to what it experiences most often. Walking is one of the safest metabolic interventions we have, supported by decades of clinical and population data. But safety does not mean one size fits all. Individuals with joint disease, unstable cardiovascular conditions, or those recovering from surgery should adapt carefully and consult medical professionals before increasing activity. For people living with diabetes, walking can significantly lower blood glucose, sometimes more than expected, which makes monitoring especially important. For the majority, however, walking improves glucose control rather than disrupting it. The purpose of movement is not punishment or exhaustion. It is reassurance. It signals safety to the nervous system and stability to metabolism. Start where you are, not where you think you should be. Move at a pace your body can accept. Then allow the system to adapt gradually and intelligently in the way it was designed to do. Your fat cells were never the problem. They stored energy to protect you. They responded to the environment you gave them. When movement disappears, they hoard. When walking returns, they release. This is not willpower. It is biology responding to signals. Walking tells your body that energy flows, that storage is temporary, that survival does not require hoarding. So here's the question worth sitting with. What surprised you more? The timeline, the biology, or the realization that your body has been trying to help you all along? If this helped reframe how you see your body, consider liking this video, subscribing for more evidence-based science, and sharing your own experience or your family's story in the comments. Someone reading may need it, and when you finish here, go take that walk.